This is what you will receive or should receive minimally from whatever your eBay vendor is. Essentially, it's the PIC3 or PICKit3 programmer, USB cable, and this jumper cable that will basically connect the programmer to the adapter board or the in-circuit connector on the developer board that you're using. In our case, it's going to be an adapter board. What you will want to do is it's going to come with both ends with the piece here that is basically a male header at both ends. You'll want to keep one in and take the other one out for use. Now this cable is multicolored. Let's see if I can get it to focus in here just a little bit. But basically what you're going to do is you're going to pick one end of this cable, or one side of this cable. Either the brown or the blue is going to be considered your pin 1. Doesn't really matter. You just need to pick a color and then stay with that consistently. In this case, I've chosen to go with the blue to reference it as pin 1. You can see the arrow here that is indicating pin 1 on the programmer. So this now is going to be our connection on the programmer. You see the USB cable connected and our jumper cables connected as well. Okay, in this situation I have the PIC programmer connected to my powered USB hub. Right here. Focus, there we go. Alright, now one of the things I've run into in my experimentation here is that sometimes when you're trying to program and provide power through the programmer for the PIC, you're going to run into error messages indicating that your source, in this case say the USB hub, is not providing enough voltage. I've simply unplugged the USB cables that you see plugged in here and reattempted the programming procedure, and that has solved the issue. So if you run into that and you're using a powered USB hub with other USB devices connected to it, just unplug them temporarily and you should be good to go. Now, again, in this particular instance, I've been using the programmer to go function of this PICKit3, so that's why you see that blinking light. It's currently programmed with a file for in its memory bank there, and right now if it's connected to say an adapter with a PIC in it, compatible PIC, all I need to do is press the button on the PICKit programmer and it will automatically program, and it'll continue to do that every time you press that that button. Let me see if I can zoom in here and show you where that button is located on this particular device. It should be right above that top LED. If you see that black area there, that's where that button is located on this particular clone device. Now if you want to use the programmer to go function of this clone PICKit3, this is pretty much the only connection you need to have at this time. This is basically a procedure that you know, if you're doing say 10 of a particular type of PIC MCU with particular same firmware for each one. You can basically connect this up with your adapter board and just simply swap out the chips as you program them. And once you've done this, you don't have to have the computer running. Like I said, it's good for multi chips that you want to program with the same firmware. It's not, if you're only doing one of each, then it's probably not going to be as economically for you to do it this way time-wise. I'm going to try to show you both options, how to do both options. One example using the programmer to go and the function, and the other to do individual programming using the PC and the software to control the programmer. The PICKit3 programmer is currently in programmer to go mode. You can tell by the blinking active light there, and it is currently connected to a homemade adapter board. This adapter board is, like I said, homemade. I currently have the blue pin highlighted here or selected here with the arrow key. It is going to pin 1 of my homemade board. That's your VPP. This board has 2 connection points, one for the 8-pin PICs and one for the 18-pin, with 2 separate connectors, one for each. The actual use of the programmer to go function is very, very simple. Once you have it connected, you don't need the computer running. It just needs to be plugged into a powered USB port, a powered USB hub, something like that, that is capable of plus 5 volt source power. And what you would do is simply press the button right above the power light one time. That will turn the PICKit3 programmer into automated mode. It will go through its procedure there, and depending on the size of the PIC that you're programming, it may be a very quick programming. It may take a minute or so. So sometimes if you blink, you're going to miss it, and sometimes you'll actually see the active and status lights blinking as it's going through the programming. With this particular clone, one thing I've noticed, it doesn't follow the microchip original PICKit3 LED lighting legend. If there was an error or if it completed, you would get the status light to light or stay lit or not. And in this clone, you'll see the status light blink a little bit, and then it will go out. But that does not mean that it failed. That kind of confused me initially, because I was expecting that if it failed, that status light would go on and stay on. In this particular clone, they apparently chose not to get the bi-level LED. They substituted a single color, and so if it programs okay, that status light goes out. In the original PICKit3 programmer from Microchip, If there's a failure, you'll see that status light light up red. Otherwise, it should be green. So, like I said, in this particular case, all you're going to do is press the button, in this case, because there's no PIC in the sockets, it's given me the flashing red. Otherwise, it would simply go out and not come back on. That would be an indication that the programming completed, and it would go back to the blinking active light telling you that the PICKit 3 is now ready to be used again.